Everyone, I'm Gleb Bahmutov, and I'm here to talk about self-improving software for Node Week. Thanks to Node Week for inviting me and letting me speak on this topic. A few words about myself. I work at a company called Kensho in Boston. We do software analysis for statistical data for financial industry. We're both in Boston and New York. And I do Node.js services. And the question I'm always trying to solve is this. Every time we start a greenfield project, it's simple, but after a while, it starts looking like this. This is a picture of electronic tunneling microscope, and it should not be this way. Most of our code should not be this complex. Most of our code should be pulling data from a database and showing to a user. It should not be complicated. And so I'm here to show a better way. The outline of this presentation has 5 parts. First, I'm going to talk about large code bases and then how we solve the problem of large code bases by dividing them into smaller modules. Then we have to talk about semantic versioning, right? What NPM uses. And then we'll talk about 2 things that will make semantic versioning work in reality, which is save dependency updates, and then how do you actually release software so that you don't break other people so they can update. So let's start. First, let's look at some red flags. If you have any of them or many of them, then maybe your source is out of control. For example, if your build time, transpiling, bundling, is longer than 15 seconds, if you actually break your attention while waiting, then it's a red flag. If you cannot really unit test a feature, if you think it's too difficult or impossible, that's a red flag. If you have multiple tools that you have to use in order to actually test software, if you have multiple environments, let's say a database, a server, and a front end, that's a red flag that your code base is too large. And finally, kind of semantic. If you're trying to describe the project and you have to use the word "and" a lot, then that means the project scope is probably too large. It's a red flag that maybe things should be split and separated. Often people have to get the source, build it, and test it. And if that process takes a long time, that's a red flag in my book. If it's hard to reuse code because everything is bundled together, everything has dependencies on each other, that's a red flag. And finally, in human terms, if you ask a developer, hey, can we fix this bug or can we add a feature, and he or she says, well, it's kind of complex and I don't really want to do that, that means people are giving up. And that's a huge, huge red flag. It's all relative, obviously. Whatever you consider a large code base might be small to another environments. On one extreme, we have single functions where a module it just implements a single function and that's it. On the other hand, we have giant single repository companies like Google or MathWorks where I worked, where everything was in a single repository together. I kind of land here where several files that are related to a single feature should be a separate repository, right? So I'm not as extreme to put every single function in its own repo, but I definitely want to have just a few things together, and that's it. A lot of things are actually simpler in a small project. For example, the scope, the reuse, documentation, testing. It's much easier to document a small module than a large one, and I think that psychologically, is better. But other things are also simpler. For example, API design. Code reviews and standards are actually doable on a small project. Installation deployment are much, much simpler on a small project than on a large project. Onboarding, getting new developers to contribute is simpler as well. There are a couple exceptions to the rule. Obviously, if you have a single product and a bunch of plugins, it's easier to keep them all in sync and together. Notable projects that use monorepo Babel and PouchDB, where things are still separate modules, but inside a single repository. But it's just an exception, not the rule. Why, if you have a lot of code, it actually makes it difficult? Well, software complexity increases with number of interactions. Let's say you have this function, right? It's a function call to add of 2 arguments and a sum. Well, there are 4 variables, A, B, add, and sum, and they all can interact with each other, right? So 4 variables, each can interact with 3 others. It's 6 interactions. And the brain research people always say that your mind is limited. It can only hold, at most 7 things at once in its short-term memory. And we have a solution, right? In order to reduce the cognitive load of your code or physical things, you have to physically separate them. A good example is this box. It has a couple inputs, a couple outputs. Inside, it's pretty complex, but we don't have to think about it because we physically separated everything inside of a box from it outside. We have good examples of physical separation in our code. For example, a function physically separates internal code from the outside. We don't have to think about the inside of a function to use it. Similarly, a module separates its code from anything, from its dependencies or anyone who uses the module. There is a pretty well-defined boundary between the module and its users and its dependencies. So functions separate variables via scopes. Source files separate code. Dependencies separate files. We separate teams, people using teams. And even when I'm making this presentation, I'm separating bullet points and all the things I'm trying to say physically from each other by using slides. Let's quickly compare how we create software to how we assemble a car. Each auto part that goes into a car is built separately, right? A single factory is not building both the windshield and the tires. Each part is tested separately. It has its own specifications. It has a number that tracks it. So if you need a part that performs according to specification, you just look it up by number. Each auto part is shipped separately to auto plant, and then everything is assembled together. If we're trying to build our applications the same way as we assemble cars, there is a good guide to doing that. It's Heroku's 12-factor app. And a few principles are really sticking out to me. For example, we do not build cars and boats at the same plant. Similarly, we should not build multiple things, let's say API and your website and your database layer in the same repo. We should separate them and build them separately. We don't want to build cars and tires at the same plant, right? So we want to share code through dependencies and not through physically locating the code together. Finally, even if new parts are manufactured, you still have original parts manufactured according to specifications. That way you can replace a broken part. Every library in software should have its own version, and if you need older version of software, just bring an older version. So let's talk about NPM, right? The largest repository of code, the thing that we all love to use. An NPM module has a name, but most important, each module has a version. You can bring dependencies and bring additional features from these dependencies. You can specify versions using fuzzy numbers, tildes, and caret. And actually, I don't like that, because the build is not repeatable. It might work on my machine this one time, but when my user's actually trying to bring this, then everything breaks, because they actually bring different versions of dependencies. I prefer using exact dependencies, and yes, this blows up the size of Node module folder, but I think this is a much safer if you actually use exact dependencies. There are other solutions like shrink wrapping, but I prefer to always specify exact versions. I only worry about the top level, right? So if my package on top uses a couple of dependencies, I don't care the internal implementation of the top level or of a level below. I only care about the versions of the top dependencies, but not how they're implemented internally. And I specify exact versions of my top dependencies in my package.json. So we talked about large code bases. We talked about dividing code into separate modules for simplicity. Now let's talk about semantic versioning. So the idea of semantic versioning is that every package, every library has a version, and the version has 3 numbers. And the numbers are called major, minor, and patch. This kind of fuzzy terms, I prefer thinking of break, feature, and fix numbers. And the meaning of this really is like that. A major, or first number, means I'm the author of a library, I change how it works. I change its API, and so you cannot really upgrade to this version. It will require some changes to my user code. So that makes me kind of angry. Minor number upgrade means I added a new feature. But if you're using existing features, you should be all set. It should not require any changes to the client. And a patch, the last number, means I fixed something, but there are no new features and there are no API changes. You should be able to use the patch version right away. Quickly, let's think about upstream and downstream. Let's say we have a module and it depends on some other modules. That module that we depend on is upstream. If there are any changes, a new version release, then it's upstream module and we should update. But also we release a version, so our clients can depend on us. So these modules will be downstream from us. They will upgrade when we release a version. When we start development, we usually have latest versions of dependencies. In this case, 0.10 and 2.2.0. And then the next day, one dependency can patch a couple bugs. So they publish new versions, and we still use the old version, and it's fine. Next day, a different dependency might actually release patches, new versions, and a new major upgrade where API changed. The question then arises, can we actually update our dependencies? Can we update patches? Well, we should be, right? Because patch means there are no new features and no API changes. It's just bug fixes. So we should be good. Well, if it's a new feature, we should be able to upgrade because there are no API changes. We might not need this new feature, but we should be able to update. And finally, the major version upgrade means there are API changes, and we probably cannot upgrade without doing extra work. But this is all in theory. In practice, no one knows. A patch could actually break something. We could be able to upgrade through major version because we're not actually using the part that changed. So no one really knows if it's safe to update our software if our dependencies release new versions. Relying on human-supplied semantic version numbers is like relying on code comments to be 100% accurate, and we all know that the code comments are not checked by a machine and cannot be relied upon. So the question arises, if we split our large repository into a bunch of small modules, now we have to worry about upgrades and version numbers and human version numbers. Is this going to be a mess? And the honest answer is yes. But the mess is manageable. All these constant upgrades can be automated. And this maps nicely into how we develop software. Different libraries should be able to be developed separately at different speeds, right? And that's what this development model, where you separate everything and you develop everything separately by versions, should actually be a nice development model. And it really separates this thing where you put all the code together and different parts can actually touch each other, and you constantly have to worry that a single commit can break everything around it because there is no physical separation. if we actually build our electrical system the same way we build software, then every time we change a light bulb, we would have to go and check that our power plant is still working, just because everything is dependent on each other and everything lives in a single tightly coupled system. In practical terms, today's development means if I have a function add and I change something, I have to guarantee that every time this add function is used in my source repository that I have not broken anything, because it will be harder to revert a commit. But if we develop the software separately, then we can build a version, let's say 1.0.0, and then my users can use that version 1.0.0. And then I can develop version 1.1.1 where I change something, maybe optimize how integers are added for performance. The user of my package add now does the integration or upgrade separately. First, you increment the version, you install it, and then you run tests. So it might pass in a couple places, but then one place might show an error. So something about adding 0 and to 0 broke. Well, we only tried this, and it's easy to go back and revert by just going back to version 1.0.0 that works. No harm done. The question then arises, can we automate dependency upgrades? Can we bring the new features, the bug fixes, without doing this process manually? If we wrote an algorithm, it would run unit tests first to make sure we have a stable state. It will install each new dependency and each new version and run tests again. If the tests pass, then we can keep the new version. If the tests fail, we have to revert, and then we continue as before. This process is easily automatable and it's safe. There is a tool called Next Update that I wrote that does exactly that. It runs each library separately, reports if tests pass or not, and then it even gives you a command that only upgrades the versions that safely passed tests. The only requirement that your software has to have is that you have to have tests. And having good tests with good coverage is required anyway for good quality software. If you test your software, you can get third-party upgrades with zero effort by automating this process. If you have a lot of projects, you don't have to upgrade each one separately. There is Next Updater that runs safe updates on each project independently and then commits it back. Finally, a couple of very smart people started greenkeeper.io. It's a dependency update as a service. It integrates with GitHub and Travis, and periodically it monitors your dependencies, and if there are new versions of dependencies, then it will create a pull request only if a CI build is successful. So it will not spam you with failing merge requests. Instead, it will open a pull request only if the version upgrade is safe. There is a question, obviously, well, can I actually trust this update? Is the update from, let's say, version XYZ to XY+1, which is a minor version upgrade, is it likely to succeed, even before you do anything? Every time you use Next Update, it anonymously sends success or failure for each upgrade for public modules. There is a website that I run where you can actually look up how successful an upgrade from one version to another was. Obviously, it doesn't know which particular features you tested, but it knows that in total, across the internet, such a high percentage of upgrades from one version to another has been successful or not. It even prints this table when you run next update. And so you can judge for yourself if a particular upgrade is likely to succeed or not, if you should trust it or not, if it's dangerous or not. Interestingly, by using this information, you can measure how closely a library is adhering to semantic versioning, if they actually respect it, or is a library actually likely to release, for example, a minor or a patch upgrade that will break when you try to actually upgrade. A library like Lodash, for example, is following semantic version very, very closely. And if you use version 4 of Lodash, you can safely upgrade to 4.1, 4.2, and so on without being afraid that you'll introduce a breaking upgrade. Should be afraid of automated upgrades. Well, periodically, even my TV is asking me to upgrade its software. I'm actually scared of this more than I'm scared of NPM version upgrades, because I never know if my TV will allow me to downgrade if something goes wrong. iOS operating system for my phone, for example, switched from manual updates in iOS 6, where I had to trigger an update, to automated updates. For example, in iOS 7, you could just set a flag, and then all the apps would be upgraded automatically. So it shows that software vendors like Apple actually trust automated updates enough to kind of release it into the wild. And I think automated upgrades for your NPM dependencies should not be that scary, but only if your project is well tested, and only if a particular dependency has a high probability of being successful. And we can use data from next update to decide that. We can also say, well, only trust patch updates or minor version upgrades. So this allows you to automate dependency updates. We still have to talk how to safely release new versions so that your software doesn't break everyone who uses it. And for that, I use a great tool called Semantic Release. This is this tool from people who wrote greenkeeper.io. It's a single line installation. When you run Semantic Release CLI setup inside your project, you just have to answer just a couple of questions. It basically just grabs your GitHub and NPM tokens, so it can release on your behalf. And all you have to do from now on is, when you commit new changes, is to use a special commit format. It's a convention, it's not a standard. In this case, for example, I'm committing and I give a comment minor app, in this case is scope, and then actual comment. And when I push code, then my CI will run tests, then it will trigger semantic release that will look at my comments in my Git log. If it finds any comments that follow this format, where it's like minor or major or patch, then it will actually compute new version. In this case, it will be a minor update. And only if tests pass, it will release a new version, completely automated. The human is taken out of equation. This commit message convention, for example, in this case, a new minor version is published. If you use patch and major, let's say you have two commits and then you push the code, when the larger one wins, you can release just a patch by pushing it right away after you added a patch. There are several commit conventions. For example, there is conventional commit message convention that Angular team uses. I prefer what I call simple commit message. You see it right here. Once you release, once you automate, the question of are you going to break everyone is very, very important. So how do you know that if you push a patch, then the users actually are safe to upgrade? Well, let's write some more tooling, right? I wrote a tool called Don't Break. And the purpose of Don't Break is to test your new code before you actually release it against any library that depends on it. And for example, you can test your library against 100 most popular projects from NPM registry, or most starred or most downloaded. In case of Lodash, you can test Lodash version before you actually publish it against thousands of projects that use Lodash. And the principle behind don't break is pretty simple. Let's say you run don't break from your module X. You install each dependent project that uses current version of X. And then you replace the current version with the software that you are about to release. And then you run the tests for that particular module. If the tests pass, when everything is fine, feel free to push the module. But if for some reason you're breaking the unit tests in dependent projects, then you cannot release it as minor or patch. Maybe you have to release it as a major upgrade, a major version upgrade. So from Lodash, if we find that a new patch actually breaks the dependent modules that used to work for version 4, maybe we have to release this as Lodash version 5, for example. If you use Semantic Release, like I recommend for everyone, there is a plugin that just wraps this functionality, and it's called Don't Crack. And so it will run on your CI, so you don't have to run it manually. And now you will be safe to know that minor or patch release will actually work. I described all the steps that I take in order to publish software on NPM in this blog post. But to summarize, it's all automated. I only work locally, and I only think about commit messages. I don't have to worry about what version I'm releasing, or that I have to do it today or at the end of a month. It all happens automatically and as many times as necessary. I wrote recently a module for snapshot testing called Snapshot, and it actually shows how I test and upgrade software really, really well. So first I wrote Snapshot, and then I try to test it in many, many different situations. For example, I try to use Snapshot with Jest, with Ava, with Vue.js, and other projects. So instead of adding all these different test runners and all these different bundlers and environments into Snapshot, increasing its size and making it really complex to actually use and test, I created separate GitHub repos and NPM modules. Now, after writing that, I wrote something else called SchemaShot. It's also for snapshot testing, but using schemas. Again, separate project, separate module. Now, Snapshot and SchemaShot shared a lot of code, which I moved into Snapshot core. So now we have these 3 levels of dependencies, upstream and downstream. Now we have to actually work with all these modules. So how do we do it conveniently? Well, Snapshot core releases new versions using Semantic Release and Don't Crack, just to guarantee that a patch will not break SchemaShot and Snapshot accidentally. Yet these projects don't trust it automatically, and instead they automate the upgrade to Snapshot core using greenkeeper.io. So every time there is a new version of Snapshot core, a greenkeeper will make a pull request and I can upgrade, but I know this upgrade will not break me. Similarly, every time I release a new version of Snapshot, the Don't Crack plugin and Semantic Release pipeline will make sure that all the test projects, well, like 6 or 7 of them, are still working, so that my users are not going to break if they try to upgrade or if they use a fuzzy version. So it's a good example of how we can automate both upstream and downstream dependency upgrade. In conclusion, if you have a huge project and it's getting complex, it's getting out of hand, you probably want to start splitting it up and use physical separation to make reasoning about each project and developing it simpler. You can automate how you publish new versions of your NPM modules using Semantic Release and tools like Don't Break to make sure that you upgrade in responsible semantic manner. You can automate dependencies and upgrading dependencies, so you bring new features, new patches using tools like Next Update and Greenkeeper IO service. But I have usually people ask me a couple of questions, and one question that's asked right now is that doesn't this require a lot of extra work, right? Because instead of setting up testing and semantic release and testing and dependency upgrade once, and then sharing it across all your code in a single repo, you have to do it over and over for these small modules. And the answer is yes, it's extra work, but this extra work is so repetitive that can be easily automated. For example, if you want to automate semantic release with Crack, I have a Yeoman generator for Node projects that just sets everything up for me. If you want to automate dependency upgrades, you just go to Greenkeeper and toggle a switch, and you get all the saved upgrades. So yes, there is extra work, but it's easily automated, and it's already done for you. Another question that I see is, if we actually upgrade every time we have API breaking changes, then it will lead to projects having a large number in front. Let's say instead of Angular 2, we would have like Angular 10.0.0. And that looks weird and probably doesn't give users a good idea of development. And I can answer that particular question like this. As a user, I'm fine with using Angular 10 or Low-15 or Backbone 50 and so on. What I don't like is when I try to do a small patch upgrade and let's say upgrade from Angular 1.2 to 1.3 and not being able to do that because there are incompatible changes and the API has changed. Like, that's not okay. I'm okay with using large numbers for a version. I'm not okay not being able or not knowing if it's safe to upgrade. And so this is the end of my presentation. You can find the slides at slides.com/Bahmutov. You can also find a lot of blog posts about this type of modular development on my blog. And cheers. Talk to you guys later.